Omicron, Theta, Omega, oh my. There are hundreds, if not thousands, of books, articles, and videos discussing the subject of big O notation in computer science. So why am I making yet another video on the subject? Well, I am creating this video for several reasons. One of which is to target those individuals that are new to computer science who have not gone through a formal course of study at some academic institution and have not studied formally big O notation. So the big O in this case is not referring to the big orgasm. It's actually, in fact, referring to the Greek letter Omicron, which in big O notation is referring to the worst case scenario. And so there are two other Greek letters that we need to be aware of in the study of big O notation, and that is theta and omega, the average case and the best case scenario. We really don't care about the latter two. We only care about the worst case scenario. So you can think of this as a form of Stoic philosophy. Okay, which, by the way, I recommend reading Marcus Aurelius' Meditations in this troubled times. So why are we concerned about the worst case scenario? Well, we care about the scalability of our code, the scalability of our apps. Well, why do we care about the scalability of our apps? Well, if we are building a commercialized application, okay, then we care about how the application will behave and work in all aspects of how an application behaves and work if we were to get more customer and a company grows. And conversely speaking, if we are building a non-profit, not-for-profit application, let's say in the medical field, right, for public health, then we certainly want more and more patients to sign up for that app. And over time, we would presume that the patient base will grow larger and larger, and we want to serve all of those patients in an efficient and timely manner to get the health issue resolved, right? So that's why we care about scalability. And that's why we care about the worst case scenario of our code base. So the worst case scenario, for example, let's say we have an input array of, say, ad infinitum, meaning it can go on to thousands, millions, hundreds of millions of patients, okay, or hundreds of millions of customers. How is our code base going to behave? How is our app going to behave if it grows? So that's why we need to study big O notation to have the most efficient time and space complexity for our code and to apply the best algorithm to scale our app efficiently as we go along. We really don't care about the average case per se, because that's not what keeps us up at night, right? We worry about the worst case scenario because potentially that's what's keeping us up at night, right? Now, if you really, really want to go full bore stoicism, okay, we should really be keeping our enemies awake at night, okay? Anyhow, so the best case scenario we don't care about. So the best case scenario would be like, a constant time. If you were just notifying a customer that a patient is due, our payment is due, or if you're notifying a patient that they have an appointment tomorrow, that's easy. Okay, that's a constant time. That's all of one. Okay, so hopefully that makes sense. Now we're going to cover a little gotcha that you might see. So I would like to offer a useful takeaway from this video as you go along your study of data structures and algorithms and the study of big O notation. So let's say we were to invoke this demo function here, which has two for loops in it, and then we invoke it with, say, the best case array, which only has one string in it, and then the worst case array, which has a bunch of items in there. Obviously, this is for demo only, right? Just presume that this is ad infinitum. This goes on with 100 million items in this array. So your natural inclination would to presume that each one of these for loops would be an O of n, right? That's actually incorrect. So we have to consider this separately. As you notice here, I have this note. I noted this as O of input A and O of input B, right? So because this array only contains one item, right, which will be constant, and then this array contains millions of items, the actual, so this will result in O of input A plus input B, okay? And this is the best we can simplify this equation, okay? This is not O of n, okay? Because these two inputs are different. So therefore, our time and space complexity will be different. So keep this in mind as kind of a gotcha as you go on your journey of studying big O notation. Okay? Well, thanks for staying with me to this video. If you're not a subscriber, please consider subscribing. If you are a subscriber, thank you for going on this journey with me.